In the previous video, we explained how to match a suitable BMS to your lithium battery pack. But there are other BMS types too. For example, this BMS can be used for both series connection and parallel connection. Okay, what does that mean? We shared it earlier. If you want to choose a suitable BMS, you need to count your battery strings first. Got it? Like Li-ion for 13 or lithium iron phosphate for 15 strings. The BMS that can be used in series can operate within a certain range of series connections. It can fit on that. Also, it can work with different battery types. Additionally, regarding the BMS used for hybrid or downsampling applications, the wiring method is somewhat different from that of the fixed series type BMS. So here's the question. It sounds like the BMS functionality for hybrid and multi-type systems is even more powerful. For example, it can accommodate different types of batteries as well as lithium battery pack types with varying series configurations. So how we choose a hybrid string or a fixed string type BMS? Hybrid first. In my opinion, it may be more suitable for the type of batteries that you often have to make with different strings and different volts. For example, you have to make 15 strings, 16 strings of Li-ion and lithium, 48 volts or 60 volts or 72 volts. You might need this type of BMS. On the selection of BMS used in fixed string, it might be more suitable for certain fixed battery types of products to use. It also helps cut down wiring mistakes. But don't forget this. There may be some differences in pricing between the series connected BMS and the parallel connected BMS. The differences depend on the brand. There is also a type of BMS. I believe you all have at least a little understanding of this, called active balancing BMS. It's also this one. This is a built-in 1 amp active balancing integrated BMS. In recent years, with the rise and development of lithium batteries, you might be facing issues due to quality control at the source or because of some lithium battery packs that have already experienced pressure differences. The battery can't charge or discharge fully, which affects your battery life. So, a solution is needed at this time. What is the difference between the active balance BMS and the conventional BMS? We have several situations. The first, if your current lithium battery pack has a significant pressure difference, you want to balance ASAP. So the built-in 1 amp active balancing current can help you achieve this goal quickly. Another factor to consider is the price, because there are still some differences in the price between the active balance board and the conventional board. When you're trying to prevent pressure differences that may occur in the battery pack later on, or due to self-discharge caused by lithium iron phosphate cells, then a regular BMS can also meet your needs, okay? For example, in the case of some large capacity battery packs or relatively large voltage difference, you can also choose the built-in 5 amp active balancing BMS. Another type of BMS that has become particularly popular in the past 2 years, called the BMS for starting with lithium battery equipped for truck startup. Let's take this BMS as an example. It's an 8S 24 volt 150 amp lithium iron phosphate BMS. 150 amps refers to the sustainable current that can be passed through. It talks about the working current when you use the air conditioning while parked, with a maximum capacity of 150 amps. And the continuous 150 amps corresponds to a peak current of 2000 amps. This peak current refers to the maximum current that can be supported at the moment you start the truck. This type of startup BMS will add a few extra special features. For example, what does it mean to forcibly start by pressing? When the lithium battery of the truck is using electricity in the parking air conditioner, what if the voltage is low? Can't start it. Then all you need to do is press the start button. You can either use the app or the manual switch to force the battery to discharge. This way you can start the ignition. Additionally, some features like the heating module will be built into the BMS. This will be more suitable for us to produce lithium batteries for trucks. If your truck will travel all over the country, especially in the cold northern regions, in a low temperature environment, as you know, I don't recommend charging lithium batteries at this time, so a heating device is needed. Of course, it is also necessary to equip the starter BMS with a heating module. Additionally, like other communication ports such as GPS, then remote control of the lithium battery pack can be achieved. Remote viewing of information, including electric heating information, is achievable. Overall, the above content basically covers the relevant information for selecting a lithium battery BMS in various civilian application scenarios. Did you get it? What else do you want to know? Let me know.